What happens when we throw a ball from the surface of the earth? That ball will move up, stop, and then again come back on the earth. But what if we don't want the ball to come back to the earth? We will have to increase the initial velocity with which we throw the ball, right? But we know that gravitational force still will pull the ball in the downward direction. That means we will have to throw it to a distance where the gravitational force does not act. But we don't know what distance should we throw. That is the reason what we say is that this distance should be actually an infinite distance, because the gravitational force acts till infinity. That means the velocity with which we now throw the object such that it overcomes the gravitational force and does not come back to the earth, that velocity is called as escape velocity. Let's write the definition. The minimum initial velocity required to overcome the earth's gravitational force to move the object into space and not fall back on the earth is called as escape velocity. Now what we'll do is, we'll try and derive the formula for escape velocity. A slightly bigger derivation, but an easy derivation if you all see and if you all practice again and again. Let's see the derivation. So now what we have to do is, we have to find total energy of the ball. What do we have to find? The total energy of the ball at 2 points, that is at A, which is on the surface of the earth, and the other will be at infinity. Now, when the ball is on the surface of the earth, remember that the gravitational force always acts from the center. That means the height of the ball will be taken from the center, that is nothing but r. That means the height of the object is capital R. Remember, the height of the object is capital R. So at point A, we will try and find the total energy. But for total energy, we need to find out kinetic energy as well as potential energy. Now we know the formula for kinetic energy is half mv square. Now since velocity is escape velocity, we write v to the base esc square. And potential energy, the formula is mgh. But we have to find the gravitational potential energy. That means we need to make certain changes. So here m, small m remains small m. But do we have the formula of small g? Yes, we have. We have everything capital in small g, right? That is capital G, capital M upon capital R square. And we know that height at this surface is R. That means instead of h, we write capital R. So this R and this square gets cancelled. What remains is m, g, m upon R. We can also write it as g, m, m upon R, which is capital G, capital M, small m upon capital R. But this object will obviously go in the upward direction. That means it is going against the gravitational force. So when it moves in the upward direction, its velocity will start decreasing. And whenever velocity decreases, such type of acceleration is called as negative acceleration. That is the reason we put a minus sign. So the formula we obtain for potential energy is minus gmm upon r. That is capital G, capital M, small m upon capital R. So to find total energy, we will have to add them. That is kinetic energy plus potential energy. So what is kinetic energy is half mv to the base esc square and plus potential energy. But we know that there is minus sign over here. So plus into minus becomes minus. So we get minus gmm upon r. So this is E1. E1 means total energy at point A. You all can take TE1 or whatever is comfortable. So we have E1, that is energy or total energy at point A. Now we know that when we throw the ball in the upward direction, it will go at infinity and stop. That means now we have to find total energy at point B. So for total energy at point B, first of all we find kinetic energy, then potential energy, and then add them. So kinetic energy is half mv square. But here if you see, half mv square is the formula, right? Wherein v is the final velocity. Whenever we throw any object in the upward direction, its final velocity becomes 0. That means the value of v over here becomes 0. If the value of v is 0, that means the kinetic energy is also 0. Let's see potential energy. We know that the formula is minus gmm upon r. So minus gmm upon r. R is nothing but the distance, and over here the distance is infinity. That means we have to write minus gmm upon infinity. And anything divided by infinity is nothing but 0. That means kinetic energy plus potential energy will be 0 plus 0. That means E2 will be 0 plus 0, that is equal to 0. So E1 we have a value, E2 we have a value. Now there is something called as the law of conservation of energy, which says energy can neither be created nor be destroyed, but can be converted from one form to another, and the total amount of energy in the universe always remains constant. That means E1 will be equal to E2 because it says energy is always constant. So we write E1 on the left hand side, that is half mv square minus gmm upon r, and on the right hand side we write E2, that is nothing but 0. Now we shift this entire term on the right hand side. So minus sign becomes a plus sign. So we have half mv square is equal to gmm upon r. So we have small m and small m gets cancelled. So what remains is v to the base esc square is equal to, and this 2 we can throw on the right hand side, so it goes into the numerator. So what we get is vesc square is equal to 2gm upon r. Now to remove this square we have to take square root. So the square goes away from the left hand side, and here we have to write a square root sign. So we get vesc is equal to under root 2gm upon r. This is one of the formula that we can use or will be using in the chapter space mission, but we can change this formula. What we have to understand over here is gm upon r. There is a similar formula that we have for small g, right? But it is capital G capital M upon capital R square. So one r is missing over here. So what we do is we multiply the numerator and the denominator by capital R. So here you see gm upon r square. Just see this. So here gm upon r square is nothing but small g, right? So how do we change this formula? Under root remains as it is, 2 remains as it is, gm upon r square becomes small g, and r remains r. So this is the formula that we obtain, that is escape velocity is equal to under root of 2gr, and the reason that we write is small g is equal to capital G capital M upon capital R square. So this was the concept of escape velocity, and this is the formula of escape velocity, which is equal to under root 2gr.